Hello everyone, I'm Tian Chen. Today I'm going to present to you Polycam, a state-of-the-art photorealistic 3D object capture application. And here is today's agenda. Now let's start with the very first item, the overview. Here is a demo from their demonstrating video. As you can see, the basic workflow for Polycam consists of mainly two steps. First, the user utilizes their phone to take lots of pictures with regard to an object. After that, what the user needed to do is simply waited for the 3D model come back from Polycam's cloud server. Quite simple and easy to use. The rationale behind why I chose this app as my presentation target is started from our 3D reconstruction homework. Within that homework, what we finished is a sparse point representation of the scene we constructed. So that really makes me wonder, there are tons of 3D scanner apps out of there, right? So how did they manage to finish such a dense reconstruction of an object? Luckily, I found my answer in this app. Therefore, I decided to also show the resolution to all of you since I believe this could be quite an interesting extended reading. So now, before we dive into the tech side of this app, let's take a look at the best practice on using this app. As you can see, first, we have to take tons of images with an object. And then we will manually select which images we want to send to the cloud and which images we don't, because the image quality is gonna really influence the reconstruction quality. And in this step, we will choose how big our models are gonna be. Like you can see, you can say medium and high quality or full quality, lots of that. And boom, here is the 3D reconstruction result sent back from the cloud to us. Quite a decent reconstruction, right? There are lots of details going to be sent back. So now let's talk about what that is could happen. Although the final 3D model is absolutely a synthesis of multiple 3D reconstruction method and machine learning, it is primarily relied on a method called multi-view stereo. Now let's look at the math of homework 4 again. The core idea behind that sparse point reconstruction is recover depth information via the rotation and translation matrix and the point correspondence across all of the images. But recall that no matter we're using SIFT or BRISC, a good correspondence is always going to be located at corners. And that's what makes our construction sparse. So how to solve this issue? Well, the multi-view proposed that instead of calculating the depth, we start with guessing that depth. We margin the ray that shoots through a certain pixel, and for every possible depth, we compute coordinates on all other neighborhood pictures. And in this way, we will get lots of images patches from these neighborhood pictures. And if the depth is the true depth we want to find, all of those pictures patches shall be agree with each other. And we will get rid of the sparse correspondence and be able to find the depth for each of the pixel on our target object and thus finish a so-called dense reconstruction of the object. Hopefully, I didn't make you too confused at this part. And now let's talk about the actual user experience. For me, most of the part is decent. It has a quite straightforward user interface. The reconstruction result is great, and it even has a recently added video mode that allows the app to automatically capture the video for you when it decided it is time. I think maybe the biggest problem currently with this app is its cloud services. As you can imagine, the multi-view solution is quite heavy and it can only run on GPUs. Even that it is still very slow. In general, it takes me more than 3 minutes to get my models back. Also, it will also raise privacy concerns since all the computation is done on the cloud. As a wrap-up, here are some other scanner apps. The 3D scanner app, I believe it is utilizing Apple's LiDAR system to get the job done, while the Qlong app is also kind of includes the multi-view solution. And that's all for today. Thank you for listening.